Okay, question 11. Circle C1 has center A minus 2, 9, radius 5, and then circle C2 has center B 10, minus 7, and radius 15. Show that C1 and C2 touch. Justify your answer. What we need to do now is find the distance between the two centers. Okay, if they do touch, we're going to have, and let's just do a quick sketch, right? Just draw two circles here. Doesn't matter, as I said, about the scale, right? We just want to get two different circles where they touch. Okay, so if I got this circle here, radius 15, so we call this circle C2, and the center here is 10, minus 7, okay, and then this circle C1, and the center here is minus 2, 9, okay, so that's my A there for circle 1, and that's my B there for circle 2. Now, if they touch, okay, then the distance between the two centers, okay, should equal the two radiuses added together. So if we've got the radius of circle 2 here, which is 15, radius of circle 1, which is 5, okay, so the distance between the two centers should add up to the radiuses. So if I call this C1, C2 to be the distance between the two centers, okay, then this should equal the radiuses 15 and 5 added together give you 20. So all we got to do is work out this distance of the centers C1 and C2. I've called it C1, C2. I could also call it AB. So AB would equal, using coordinate geometry now, of course, x2 minus x1 all squared plus y2 minus y1 all squared. So that will equal to, if I take this as x2, so that'll be minus 2, take away 10 all squared, plus then 9, take away minus 7 all squared. So this will be minus 2, minus 10 is 12, minus 12 all squared is 144, and then 9 minus minus 7 is 16, 16 all squared is 256 on my calculator, and then that will become square root of 400, which is 20. Now look at that there, AB is equal to 20, which is the two radiuses, 15 and 5 added together. Okay, so we can say circles touch. Okay, and if you want to be even more information here, you want circles touch because distance between centers is the same as both radiuses added together. Okay, so that's part A answered. The second part then is, given that the circles touch at the point 1, 5, find the equation of the common tangent. So suppose they touch there where I pointed out, and we want the tangent. Now the tangent, of course, is going to look something like this, touches the circle, and it is a common tangent because if they touch here, it'll be at a certain point, specific point, which they've told us to be 1, 5, P 1, 5. So it actually, at this point is where they touch. So there's your tangent there, the point. We just need the gradient now of this line. You know, to get the gradient of this tangent, okay, what I would do is work out the gradient of the radius first. Alright, I think that's the key to this. Working out the gradient of the radius. Once you've got the gradient of the radius, we can find then the gradient of the tangent, because of course they're perpendicular to each other. So the gradient of the radius then is going to be y2 take away y1 all over x2 take away x1. Okay, so y2 is 9 and y1 is 5, so 9 take away 5 and x2 is minus 2, x1 is 1, so minus 2 minus 1. Okay, so that becomes 4 on the top, this becomes minus 3 on the bottom. So that's the tangent, of course. No, sorry, that's the gradient of the radius. To get now, because we know that, to get the gradient of the tangent, we need to use that m1, m2 rule. Okay, so m1, m2 equals minus 1. Alright, so that means m2 will equal m minus 1 over m1. So m2 equals minus 1 over 4 thirds on the bottom with a minus there. Flip that fraction then, so you get 3 quarters. The 3 at the bottom goes to the top, and the 2 minuses disappear, it becomes a plus. So you've got the gradient then of the tangent is 3 quarters. The equation then of the tangent will be y minus y1 equals mx minus x1. Your point is 1, 5, so you've got y minus 5 equals 3 quarters x minus 1. Take the 4 up, so you have 4y minus 20 equals 3x minus 3, and then you've got your answer there. You simplify that, 4y equals 3x plus 17. Okay, so there's that one done. Part B then, it says Gareth has been asked by his teacher to investigate the properties of another circle, C3. He claims that the equation of the circle is given by this. Show why Gareth cannot possibly be correct. Let's look at this in a bit more detail. Of course, when we're given a circle, we often are interested in the centre and the radius. Let's try and work out the centre and the radius here, see if it makes sense. So group the x's together, group the y's together. So you've got that. Then let's complete the square. So you've got x plus 2 all squared. So halving that. Take away then the square of that, which is 4, plus then y. Halve that is 3. Take away the square of that, which is 9, plus 20 equals 0. So you have x plus 2 all squared plus y minus 3 all squared. Minus 4 minus 9 is minus 13. Add 20 is plus 7, but when I take it over to the side, it'll be a minus 7. That means r squared, the radius squared, is equal to minus 7. The square number can't be negative. This is impossible. Okay, you can't, square number can't be negative, square numbers are always positive. So this is impossible. In other words, this circle isn't right. Okay, so therefore Gareth is indeed incorrect. And we've answered the question.